Good morning. This video relates to chapter 1 in Chemistry 65. So chemistry is known as the central science because it deals with, it has implications for the sciences. So in this short video I'd like to show you, I'd like to tell you what energy is, maybe invite you to think about what energy is. So what is energy? I encourage you to close your eyes and think what energy is. I don't think you'll come up with anything informative because asking somebody what energy is the wrong question. If you say to somebody, what is energy? You're inviting them to failure because this is not a question that can be solved. There is absolutely no answer to the question, what is energy? And the problem is, you've asked a question about a noun. Energy is not a noun. This is a noun question, where a noun is a person, place, or thing. A better question to ask would be, what can energy do? That's a much better question because it's the question you would ask for a verb. The answer, there is an answer. Energy can do work. This is a better question and answer combination because it's much better to think of energy as a verb. Energy is all about action. Work, the symbol for work is a lowercase w. And to study energy, we're going to use work as a device to study energy. So if you imagine a certain length, let's call the length x. So let's say from here to here is the length capital X. Well, we could arbitrarily split this length up into a number of equal pieces. Let's call each piece a little change in x. So I've got 1 dx, 2 dx, 3 dx, 4 dx, 5 dx, 6 dx, 7 dx. And I know that the sum of all the dx equals the x. So if I add all the small dx's together, they equal x. This is how you might write it in English, but there's a mathematical way to write it. So sum has the symbol, it looks like a large F, but without the line through the middle. So this is sum. It's from Sir Isaac Newton. Sir Isaac Newton was a 17th century English mathematician and natural philosopher. And back in England in the 17th century, this is how you wrote the letter S. We also know from Newton, so let's finish off first off. So this is how you write sum. So the sum of all the little pieces equals the big piece. So this is how you'd write this expression in mathematics. The sum of all the little dx's is equal to the big X. We also know from the same guy, Sir Isaac Newton, we don't know that. That's something else that we know that's not relevant now. We also know that work is equal to a force spread over a distance. So work is force times distance. But here my distance is x. The distance now is some arbitrary length x. So if I combine these equations together, then I get work is the sum of the force over each incremental distance dx. So we now have an equation, a mathematical expression for work, and in a second I'll erase the board and we'll use work to look at energy in the next video.